Okay, this is a video working through two problems from the 11.3 homework, number 19 and number 21. And for both of these, you need the formula from the section that talks about the area of a regular polygon equaling half times the apothem times the perimeter. So perimeter, obviously distance around the outside, that is one that we're a little more comfortable with. And if the polygons are regular, which in both of these, you'll see that in the directions, regular just means all the sides are equal. So perimeter, once you know one side, you're just adding that up 3 times. So 12, 12, and 12. So your perimeter here would be 12, 12, and 12, and that would be 36. So in terms of the equation piece, we'll just leave the A alone for a minute. The perimeter is 36. Then you have this other thing that's called the apothem, and that is a little more challenging or a little trickier. They actually give you the apothem in the majority of these problems. It is this little snippet or this little segment drawn from that center dot down to the opposing side at 90 degrees. Okay, so with this problem then, the apothem is 2 root 3. So we're just going to fill that in there for the A. And that's, again, just this piece that they gave you. So we have half times 2 root 3 times 36. You can just punch that whole thing into the calculator. But, 1/2 times 2, that first multiplication, half times 2 is 1. So just to save myself a keystroke, I'm going to just cancel those two. So half times 2 would cancel. And then you're left with square root of 3 times 36. And for ease of typing in the calculator, I'm actually going to type it in the other direction. 36 times the square root of 3. Oops, grabbed the wrong calculator. Actually, it doesn't matter as long as we use parentheses. So grab my other calculator. Just give that a second. Okay, so let's go second square root of 3. And I'm going to close out the parentheses. That tells the calculator to stop using the square root and then multiply by 36. And we could do it the other way and you get the same answer the other direction. And you end up with 62.35 as the answer. So 62.35 is to the nearest hundredth. And that would be the answer for the area of this triangle. That's really it. If you want to verify that, just because we can and we have time on this video, and we're not going to do this, I'm not going to do this for the other one, but we'll do it for this one. If you think about an equilateral triangle, all the sides are 12. If you were to do the old school method, there's our height of our equilateral triangle. The area equation, just for a triangle, not any of this regular stuff, no apothems involved, is 1/2 base height. Well, here the base is 12. That's what the bottom piece is. So it would be half times 12 times height. Now we have to go get height. Well, how do you get height? Height you would figure out based on if we just look at one of those triangles. So there's my height, there's my 12, and here's 6. You could use Pythagorean Theorem to get height. So you could say h squared plus 6 squared is equal to 12 squared. 12 squared is 144, 6 squared is 36. So then height is going to equal height squared, would be 144 minus 36, which is 108. And then we've got what square root of 108. And from a simplification standpoint, the square root of 108, you can break up 108 into a 36 and a 3. 36 is a perfect square, so it comes out as 6 square root of 3. So our height is 6 square root of 3. And we can certainly get it as a decimal, but I'm actually doing that to prove a point here. So we have half times 12 times 6 times square root of 3. Well, half times 12 is 6. So 6 times 6 square root 3. Well, 6 times 6 is 36. So 36 times the square root of 3. That's what this is. That's what this is. So these two things are the same. The reason we use this more challenging formula, and we actually don't need it for an equilateral triangle, but you do need it for more challenging shapes, which is going to be the next one, exercise 21. So the only reason I did this here in red, so this piece that I did in red, was just to show that you can get the answer in a way that we did earlier in the year. and it will get you the exact same answer that we got over here in the black pen using this new formula. So kind of a tie to something that we've done before. This second one, if this one, what we've got 1, 2, 3, 4, 5, 6, 7 sides. So this is a heptagon. We don't have an equation for a heptagon. We don't have a way to get it other than to use this apothem method. So we've got half times the apothem times the perimeter. Apothem looks like they gave us as 2.5. So they gave us the apothem, and that it tends to be the case. And then perimeter, I have to add up 7 sides. So once I know one side, then I just will multiply by 7. So my perimeter is going to be 7 times whatever that side length is. And to get that side length, I'm going to zoom in on that little triangle they gave us. So that little triangle has our apothem, or 2.5. It's got 2.77 for the hypotenuse. And then this little piece down here, I'm going to call it x. That's that's half of the bottom side. So I'm going to get that and double it, and that's going to be the side length. So let's see, it's going to be 2.5 squared plus x squared equals 2.77 squared. I'm going to subtract 2.5 squared from both sides, and then I'm going to square root both sides. And the reason I'm leaving it this way and not typing it in yet to the calculator is I'm just going to type that whole thing into the calculator and have it do it in one step. So I'll jump over to the calculator and we'll do square root, so second square root 2.77 squared. Let me get my parenthesis in there first, and then we'll square it. Actually, I think I was right. I think I was right the first time. 2.77 squared plus, yep, this is right. Except I want a minus, don't I? So 2.77 squared minus 2.5 squared. There we go. That's what it should have looked like. And then we're going to hit enter. And that number, 1.19, big decimal, we'll call it 1.19. That is this little bottom part. We need to double that. So I'm going to jump over here and just hit times 2. And 2.38, 2.39 it looks like if we round up. That's going to be our side length. There's 7 of those. And again, instead of continually retyping this, I'm just going to go back over and hit times by 7. And that gets me 16.6 and a bunch of 9, so 16.7. Looks like a pretty safe thing to call the perimeter. And that is my perimeter, or the distance around the outside of this heptagon. And so I've got half times 2.5 times 16.7. And I actually already have that number in the calculator, so I'm just going to multiply it by 2.5 and by 0.5. So I'll go back here and I'll hit times 2.5 times 0.5 and hit enter. And our answer ends up being 20.87 if we need to go, or actually no, hang on, jumping all around here. The answer ends up being 20.8749. So actually that 9 rounds up the 4 to a 5. That 4 rounds up the 7 to an 8 technically. So 20.88. Tests and quizzes and things in the future for you are not going to get hung up a great deal on that kind of rounding. But this one does ask us to go to 2 decimals. So technically it would be 20.88 as our area if we're going to the nearest hundredth. And that is using this formula. And in this case, you had to use that formula, and you actually had to do a little bit more in order to get the pieces that you needed.